Alright, so today gets the distinction of Miss Copeland forgetting to record what's going on in second period. So this is just me at lunch. I may go kind of fast. So we're talking about solutions for this part. Most of this is just review. Remember, the important thing we need to remember about water is that water is polar, and because it's polar, it can dissolve polar things and ionic things. But it can only dissolve ionic things if the attraction of between the water and the ions is greater than the ions' attraction to each other. We're going to talk about that more later, but this is where our solubility rules come from. If the ionic compound likes itself too much, it's not going to mix with the water. They're a lot more strongly bonded together. Again, a lot more detail on that later. Remember that water can also dissolve covalent things that are polar. Alcohol and sugar are really common. Remember, those are things that have C, H, and O. So they're covalent compounds, but they can dissolve. Those OH groups help things dissolve. But do remember on the AP test, like dissolves like is a guideline, but not an explanation. So don't use that in your short answer. It's a place to start. It's not an answer. Alright. Electrolytes, strong, weak, not. So remember, to be an electrolyte, it has to be ionic and soluble. Strong electrolytes are anything that completely dissociates. Look at your solubility rules. The big things you need to remember for solubility rules for the sake of AP. Group 1, always soluble. NH4, always soluble. And nitrates. These are always going to be strong electrolytes. These things will dissociate completely. Yes. So, your strong and weak acids and bases. Remember that strong acids are this list: hydrochloric, hydrobromic, hydroiodic, nitric, sulfuric, and perchloric. If it's not on this list, it's not a strong acid. Common strong bases, come back to your group 1, and you have to look at your group 2A. Group 2A is mostly going to be the lower half, not the upper half. Weak are things that dissociate but not completely. Acetic acid and ammonia are really common weaks. We're going to talk about weak electrolytes a lot later in the semester because we can actually calculate how weak is weak and what they're going to do. Alright, remember that covalent things that dissolve are non-electrolytes. Sugar, alcohol, antifreeze, starch. These things are not electrolytes. Do not tell me they're going to be electrolytes. Those are also things you should not look up based on the OH rule. Alright, composition of solutions we looked at yesterday. Molarity is moles of solute per liter of solution. If we're preparing solutions, you weigh out the mass that you need and then dilute it in what's called a volumetric flask. So that sort of shows there. We've got a better picture down here. This is our volumetric flask. It has precisely 1 mark. It can give you exactly whatever it's measured for, whether it's 100 milliliters, 500 milliliters, 5 liters, but that's all it can do. It cannot do anything less or more than that. It's either at the mark or it's not. So watch out, AP test likes to ask about preparing solutions. Make sure we know how to use volumetric flasks appropriately. Make sure, like, there was a short answer question last year that's why wouldn't I try and measure 10 milliliters of solution with a 25 milliliter volumetric flask? It's because the volumetric flask can literally, in that case, just measure 25 milliliters. It cannot measure other things. Alright. So, Molarity, remember, has to be in moles. It has to be in liters. So if we've got 1.56 grams of HCl, and I'm trying to make a solution, I have to get to moles just like always. And so my molar mass for HCl is going to be 1.01 plus 35.45, which would be 36.46 per 1 mole. I would take my number of moles and divide by volume in liters. Watch out, because in this case you're given milliliters. Make sure you're moving 3 to the left. So it would be 0.0268 liters, and that should get you that. If you don't, talk to me. If I've got strong electrolytes, things that are going to dissociate completely, then you've got to make sure you count everything if you want concentration of each type of ion. So in this case, if I've got a 0.5 molar cobalt nitrate solution, each cobalt has one cobalt nitrate, has one cobalt, and therefore my concentration for cobalt is 0.0 molar cobalt. However, it's got 2 nitrates, so my concentration of nitrate would be 1 molar because it's twice as much. Alright, so remember, moles is molarity times volume. When in doubt, do dimensional analysis on that. It'll make your life simpler. Alright, so if I want to know how many moles of Cl ions are in 1.75 liters of some molarity. Remember, molarity means moles over liters. Therefore, molarity has 2 units. Don't try and start dimensional analysis with molarity. It will make your life so much harder. So in this case, we'd have to start with 1.75 liters of zinc chloride solution. It's 1 times 10 to the minus 3 molar, which means 1 liter of zinc chloride has 1 times 10 to the minus 3 moles of zinc chloride. But in this case, it's not asking me about my compound, it's asking me about the chloride ion. And for every 1 mole of zinc chloride, I have 2 moles of chloride. So just go one more step. Alright. And again, if I need to make a solution, it's just do the math. So in this case, I need 1 liter of a 0.2 molar solution. I know I have to start with my volume, not my molarity, so 1 liter, we have 1 liter of my solution would have 0.2 moles, and then if I'm trying to get to how many grams I'd have to weigh out, it's just 1 mole is the molar mass, and you do your math. Alright, dilution. Dilution is a shortcut, because when you dilute a substance, the number of moles of solute is going to stay constant. And molarity times volume gets us moles. So this is just telling us that moles equals moles. So you can figure out what you're missing. Be careful. We try to use this sometimes when doing titrations. It's not that safe because this is only true if moles equals moles. If you've got coefficients in your balanced equation, life gets more complicated. When it comes to solution reactions, you're better off doing dimensional analysis, and we'll talk about that more later. But this one's just going to be plug things in and do algebra. Also remember, milliliters are okay here as long as you're given milliliters and looking for milliliters, or you've got milliliters on both sides. As long as they match, you'll be fine. Unlike your normal molar concentrations that have to be in liters. Volumetric pipettes are going to be like volumetric flasks. They have 1 mark, and that's it. They can give you exactly what you're looking for or nothing at all. Alright, and you should be able to do a molarity volume dilution. So, solution fundamentals is fair game at this point. You should know everything you need to know for that one. And chemical reactions 1 is going to be a bunch of electrolyte, non-electrolyte, strong versus weak. So work on that, ask questions if you've got them.